This is Chabot Space and Science Center's Galaxy Explorer programming team. We are comprised of teen volunteers from across the San Francisco Bay Area, and we're dedicated to undertaking various technology and coding-related projects to help benefit Chabot. We have groups working on programming apps, creating planetarium shows, making educational videos to help teach coding, and building an underwater rover.
71% of the surface of the Earth is covered in water. Water plays a huge role in our ecosystem and our bodies. Without water, we would not be able to survive. For this reason, it is important that we keep our sources of water free from contaminants that could harm us and the organisms living in the water. Some of these contaminants include human-made pollution that ends up in our oceans and lakes. Unfortunately, these contaminants are often too small to be seen by the naked eye, so it can be hard to identify whether or not they are present in the water. Scientists have to run tests on water samples to determine the safety of the water and what steps are needed to treat it. We have built an underwater rover to collect water samples from lakes in our area to see the state that the water is in. To build our underwater rover, we purchased supplies from an organization called Sea Perch. They sent us a box of PVC pipes, motors, and other materials. We used those materials to create a submersible rover that could freely maneuver in the water. We spent several weeks fleshing out the design of the rover. We went through a bunch of different design iterations, including one that would winch itself up and down from a buoy floating on the surface. We also played around with different ideas about where we should place the motors, since we had a limited number of motors we could use. Eventually, we decided to start by basically following the instructions that Sea Perch had sent us. They gave us a simple but functional foundation that we could build upon in the future. Unfortunately, before we could progress much further, the coronavirus lockdown started, and we were unable to continue.
Once we built our rover, it was time to test it. We took our rover to a pool at lunch, set it up, and attached a camera, and then put it in the water. We controlled our rover with the remote control that was attached through wires to the rover's motors. Inside the remote controller was an Arduino board, which is like a mini computer, and we programmed switches on the remote control to correspond with different motors. If we wanted our rover to move forward, we could push the toggle forward and both motors would spin, so our rover would move forward. If we wanted to make our rover dive deeper, we pushed a different button that turned on the motor that pointed up, so it would push our rover down. Controlling our rover was not very difficult, although we did have some issues with getting the rover to dive deeper because our motor was not strong enough to counter the floaties.
In the future, there are a couple more projects we want to work on. Firstly, we want to upgrade our underwater rover with different and better sensors in order to collect more data about the water we plan to study. After the rover is fitted with those sensors, we plan to take it to Lake Anza in the San Francisco Bay to collect samples of the water and then analyze the data taken from the samples. The second project we would like to work on is another kind of rover, but rather than a water rover, a land rover. This rover will go around Chabot and interact with visitors. Visitors will be able to ask questions about directions and suggestions for activities, as well as play games with the rover. The last project we would like to work on is a drone. We have already made a rover for the water and are planning to make a rover to take on land, so the obvious next step is to tackle the air and make a drone. Although operations have stalled due to COVID-19, we have continued to work together online and are planning to work together in small groups in the future.